We're going to walk through an application of these strategies and tactics that we've listed here in the form of questions. Again, the idea here is to start actually from the top of the questions, and I've put these in a roughly specific order so that if you answer yes to one of these questions, you should do that first before trying to do any of the strategies below. In addition, you'll often find yourself having to cycle through these questions, right? So you will have worked, say, partway down through some of these questions. You've done, say, conditional introduction. And then what you do is once you've set up the proof strategy for conditional introduction, you start again at the top of these questions and work your way down again. So you'll cycle through these as you deploy these various strategies. So let's look at an example. I'm going to use 1324 and 1325 from the Language Proof and Logic textbook. I'm going to stop sharing the proofs and strategies tactics. It is advised that you have this document just beside you so that you can see which ones I'm going to refer to. It's just going to be a little bit easier for me rather than having to toggle back and forth. So again, this document is up on Blackboard Learn for you. Okay, so let me switch over to Fitch, starting with 1324. In this proof, right, or in this argument, what you're being asked to do is assess whether the following argument is valid. Now, one of the first things we're supposed to do, if you look at the strategies document, is just understand what the sentences mean. So if we look at the premise, or step number one, you'll see that we've got an existential quantifier out front that is binding both instances of X here. So what this is saying is there is at least one object that satisfies both of these conditions because we've got a conjunction. And those conditions are being cube and being small. So the first sentence is saying that there exists an object, at least one object, that is a small cube. Now we're being asked whether the existence of a small cube entails the following. Notice that the conclusion here is a conjunction. It's got an existential quantified sentence as its first conjunct, and then it's gotten another existentially quantified sentence as its right conjunct. Importantly, the X that appears in this second conjunct is bound by this existential quantifier here. So this X, that means that this X here could pick out a different object than that X right there, that appears in the first conjunct. And the reason for that is because you've got two existential quantifiers. This first one is binding this first instance of X, and this second existential quantifier is binding this second instance of X. And those could be different objects, right? Those two X's are not being bound by the same quantifier out front like we had in this first one, right? In the first premise, you had a single existential quantifier up front that is binding both instances of X. So the way to read the conclusion, to understand what it means, is that it's saying there exists at least one object that's a cube, and there exists at least one object that is small. It has not yet committed to the claim that that each of those objects are the same one. It is consistent with this conclusion that they could be different, objects. Compare that to exercise 1325, sorry. So if we look at exercise 1325, here we're getting the reverse of what we saw previously. Here we're being asked, does it follow from the claim that there exists an X such that it is cube, and there exists an X such that X is small? Does it follow from that there exists an X that satisfies both being a cube and being small? One of these arguments is going to be valid, and the other one is not going to be valid. What I'm going to do is walk through one of these proofs and show you how the strategies that we've looked at can be applied. And what I'm going to do is try to not tell you which of these arguments is the valid one and which one is the invalid one. The one that is invalid, you should be able to find a counterexample for, and the one that is valid, you will not be able to find a counterexample for, but you'll be able to do a proof. What I want to do is just illustrate how the strategies will start to sort of interact with each other. So since we're here at 1325, let's start with this one. When we walk through the various proof strategies, we ask various questions about the premises and the conclusions. One of the questions that appears first that we can answer in the affirmative is the question, is there a premise with a conjunction? And the answer here is yes. The first premise is in fact a conjunction. The strategy that we should then use is conjunction elimination. So if we do conjunction elimination, I would have there exists a cube that would be from conjunction elimination from the first line. And then I would also have another possible conjunct that I could write down. There exists an x such that small x. And that also will follow from conjunction elimination. Okay, so now that we've walked that far in the strategy, now we continue on. We'll start again at the top of the list and start answering the questions. And as we walk through each of those questions, I'm not going to walk through them one by one, but you should be able to see that all of the questions we will answer no to until we get to one of the questions about is one of the premises an existential claim. And here, while one was not an existential claim, one of the steps above that we've already generated is has an existential claim, right? There exists an x such that x is a cube. So the strategy here then will be to do existential elimination. Existential elimination works by doing a subproof. So I need a subproof. And the way that existential elimination works is, since I'm using 2 to sort of kick it off, what I'm doing here is saying, okay, let me give a name to the cube that exists in number 2. I'm just going to give it a temporary name. And the important restriction is that I can't use a name that has already been used beforehand. There are no names that have been used so far, so I can use the name A to temporarily pick out that cube. And so then I'm going to say cube A. My goal in this subproof is what my ultimate goal is, which is the claim that there exists an x such that x is a cube and x is small. So the rule here that I'm using is existential elimination, citing the subproof, which in this case goes from 4 through 6 at the moment, and uses the assumption that there exists a cube. So this subproof is saying, all right, let me temporarily name this thing that's a cube A, and my goal is going to try to be to get to the claim that there exists an x such that it is both a cube and small. All right, now we walk through the list of the questions, the strategies. Again, we go from the starting again at the top, we answer questions about conjunctions, and now we have this additional assumption, right, that A is a cube, that we also want to be able to answer these questions for. So if we go down that list again, we'll notice that we won't really get to any yeses to those questions until we get to one of the 2 questions, right? Is there a step or a premise that is an existentially quantified sentence? If so, then we can do existential introduction, or sorry, existential elimination. And we also have, is one of the goals an existential claim, in which case we would do existential introduction. Now there is a preference here for trying to answer one of the questions first, right, and doing that strategy first, which is if you find a sentence that you haven't yet made use of that is an existentially quantified sentence, you should do existential elimination. So if I do that, then I'm going to be using 3. 3 is an existentially quantified sentence that I haven't made use of yet. To do this strategy, I again need to do a subproof. This time, my goal is, or my assumption is going to be to give a temporary name to the thing that is small. And again, my restriction here is that I can't use a name that's already in use. So I'm already using the name A, so I can't make use of that again. I have to pick a new name. So I'll pick B. And then I can say that B is going to be small. So here I'm using the assumption that is specified in 3 to start off this subproof, saying, okay, I'm going to give a temporary name to the thing that's small. And my goal in this subproof is again going to be this primary goal that I have in 8, which is that there exists something that is both a cube and small. So 8, the way I would justify this is through existential elimination. This time I'm citing line 3 and then this subproof. And you'll notice as we walk through this, right, if I check all of the steps, I have each of these individual steps justified so far, but I haven't yet satisfied my goal because there's 2 steps here that don't yet have justifications for them. So now, if I walk through all of those steps, you'll see that I have I'll go through all the questions. I've used up all of the existentially quantified sentences, both which were 2 and 3. Now what I have is a goal or a sub-goal that is an existentially quantified sentence. And once I get to that goal, the strategy is to use existential introduction. So here, this is a backwards working strategy. What I'm going to do is see if I can get a sentence that is something like the flavor or is going to match the pattern inside the scope of what's in the existentially quantified sentence. So I might have something like cube A and small a. Right? If I have sentence 7, then I could do existential introduction from line 7, and that would check out. Notice, in order to be able to do this rule, I have to have the same name in each of the argument positions for the predicate. This has to be cube A and small a. The rule won't work if I have instead cube A and small b. If I try that, this rule won't work anymore, right? Because I'm using the same variable x, which is bound by the same or the single same existential quantifier up front. So that means x has to be used to replace the same name throughout. So I have to have cube A and small a. That will then work. So now the question is, can I build, there we go, sorry. Can I then build this conjunction? Can I build the claim that A is a cube and A is small? Walking through the list of questions, right, you see, oh, if we got a conjunction, what you need to do is build it. You need to do conjunction introduction. To do conjunction introduction, I need each of the 2 component parts. I've got cube A, but you'll notice I don't have small a. I have instead small b. So I can't do conjunction introduction on these 2. This will fail. I need to somehow get the name of the object that is both a cube and small to be the same one. At this point, as I start walking through the various proof strategies, there might be one like that I might still be able to use, which is going to be the last one, which is do the contradiction introduction, right? Or do a proof by contradiction. If I can find some type of contradiction, then I would be able to say that if that A is a cube and A is small. So I should now look, do I have anywhere a contradiction built up? And when we go and evaluate all the premises and the sub-assumptions that we have, right? So that's to say that A is a cube and that B is small. There's nothing contradictory here, right? We haven't gotten ourselves into a contradiction. So what this then starts to tell us is maybe there isn't actually a proof, right? As we walk through all the questions, there aren't any sort of strategies that we have left. And moreover, the very final strategy that we have that should work is we don't seem to see anything that's contradictory, right? More specifically, if I do this, if I add, say, a subproof, and I'm going to say, okay, I'm going to justify this claim by doing the negation introduction, right? Negation introduction is the proof by contradiction strategy. So in that case, what I do is say, okay, I'm going to assume the opposite. I'm going to assume that it's not the case that A is a cube and that B is small. Or sorry, that A is small. And see if I can get a contradiction from that. Right? If I can get a contradiction by assuming the opposite of 8, then I'd have a proof. Sorry, I just realized that I needed to do the I needed to cite the subproof. So, right, is there anything contradictory in saying, hey, look, it's not the case that A is both a cube and small, in addition to saying that A is a cube and saying that B is small. And there's no contradiction here. So the fact that there's no contradiction here starts to tell us that maybe there's not a proof here. And in fact, maybe we could actually build some type of counterexample. So we have some pieces of information here that's helpful. Could you build a world where A is a cube, where B is small, but you make it the case that, so it's not the case that A is a cube and small, right? So say you make A a medium cube, and then you make B a small tetrahedron. If you build that type of world, and then you go back, you'll notice that premise 1 can be made true, right? The medium cube satisfies this part of the conjunct, and the small tetrahedron satisfies that side of the conjunct. So in fact, we'd have a world where this premise is true, but then we look and we see whether the conclusion is true or the goal is true, right? Is there an object that is both a cube and small? And the answer is no. We've got a medium cube and we've got a small tetrahedron, but we don't have a world where there is a cube that's also small. So here we've done several things by walking through this exercise 1325. I've tried to show you how to use the various proof strategies, right, by using that document and those series of questions. And we've gotten to a place where we don't think that we can complete the proof. And as we've gotten to that place, we're looking at the proof and some of the additional assumptions that we've made to give us clues about whether we could potentially build a counterexample. And the answer in this case is, yeah, we can build a counterexample to 1325. So while I said at the beginning that I wouldn't tell you which of the exercises of 13, 24, and 25, which one of them is valid and which one is not valid and which one has a counterexample, if you watch the entirety of this video, you should be able to infer which one is valid, which one is not, and already see how to build a counterexample for one of these.